Hello, my name is Andrei. I'm a software engineer who recently delved deep into AWS cloud architecture. Although I have theoretical knowledge on the subject, such as understanding the advantages and challenges of AWS serverless architecture, I believe the practical application is the key. That's why I decided to create a small software project using AWS serverless components. Why serverless? First, it's in demand, and AWS Lambda is still a buzzword. Second, a serverless design is not just trendy for me. I want to build an app that's deployed on a server, but mostly remains in a domain state to minimize my spendings while nobody uses it. This is a challenging task for me, but I have a plan to solve it. Before we begin, let me share my plan. I'll break this big task down into 4 pieces: design, backend implementation, front-end implementation, and finally cloud integration. Each phase will have a dedicated video. This video will focus solely on the design phase. You may find some videos to be more informative than the others. However, the most critical part for me is the one about provisioning AWS infrastructure, in addition to the design phase, of course. Before we dive into discussing the application I'm gonna build, let's talk about how you can benefit from watching these videos. This training is ideal for those who have some experience in software development, especially on the backend side, preferably in Python. For instance, you might have limited experience with building software from scratch, particularly in deploying the software product you're creating. If you are exploring AWS Cloud like I am, you might already have some practical experience with AWS. Or maybe you are looking to gain proficiency with an infrastructure provisioning automation tool like Terraform, which we'll cover in detail. Finally, you may have both theoretical and practical knowledge on all the subjects I've listed, but you have not yet designed or implemented a serverless AWS architecture. And that's precisely what we'll do today. If you want to do more than just watch the video, but to follow along with me, I'll share the link to the code repository in the video description. There are branches for each major and some minor steps we'll take. To set up your local environment, run the project locally, and finally deploy your software to your own AWS cloud, you'll need Linux or macOS on your PC. I'm not sure if Windows will work because I'll be using some bash commands. Now that we've covered everything, let's set up our goal and start designing the application. It might be a bit unusual that we first pick the technologies to master, and only then we'll decide on the application design to utilize the technologies. Normally they do quite the opposite. Our goals decide what software we choose. But presently, our goal is to build an AWS serverless application, the one that doesn't require a server running 24 hours. Apparently, the key component for the application is AWS Lambda, a relatively small software that's brought to life only when it's needed and automatically hibernated or just terminated when it's not needed any longer. But to build a finished product, we need some interaction with the user, and the Lambda unfortunately does not provide any means of interaction, but API Gateway component does. We'll be using this together with AWS Lambda to actually perform some actions, update the internal state, and update the information user sees in his browser. I'll mention the browser. That means we need a website, and we'll build a simple static website that will host in AWS S3. I also mentioned an internal state, and for the internal state, we most obviously will use a database management system, but the simplest one I could imagine, the one with key value storage that doesn't require a schema, namely Elastic Cache Redis option. All the components I mentioned are the bare minimum for the application I'm gonna create. And the application is a website that allows user to participate in quizzes. These are the requirements for our application. And the first requirement, that no registration is required, but the player has to provide a nickname that's unique for the current quiz session. The second requirement, a quiz could be a joint venture or multiplayer session. The player who created the quiz session would be the quiz commander, or the person who would invite others and then start the quiz. During the quiz session, one question automatically follows another. Time for answering each question is limited. The winner is determined by both the number of the correct answers and the speed at which the answers were given. And finally, the software I'm creating should be easily extendable. For instance, to give the players the ability to register and create quizzes of their own. This is what the user is going to see on the start page. There are two options, either starting a quiz or joining a quiz, providing the user has already received a code that the other person who started the quiz shared with him. The user types his name, selects a topic, and then starts the quiz. If the user joins a quiz, that's what he will see. Again, the form is similar. He has to provide his name and the quiz code he already received, probably through a messenger. There is a button named Join. Then the quiz has started, questions will be following one another, and the user will be selecting the correct answer or answers if the question supposes multiple answers could be correct, and then press the button. But the user will still see the same question until the time for this particular question is over. In the top right corner of the screen, the countdown timer will show the time until the next question will appear on the screen. And this cycle would repeat until the quiz finishes for all the players simultaneously. When the time's over, the quiz finishes and the results are shown on the screen. And on the left part, again, there are players, and each player has its rank, its position inside the quiz, plus the number of answers he gave correctly. And the right part is the player's answers. Both correct and incorrect options are highlighted. This design implies a quiz had a state, and the state changes over time. But the challenge is that our backend is Lambda that doesn't keep track of time. This quiz application seems to be quite a simple challenge. Personally, I'm not thrilled about the idea of implementing such trivial logic. Show the questions and collect answers. But if we build this up, if we automate a cloud distribution, this project could be a launchpad for something fancier. Let's say I'm going to implement a chess application, and surprisingly enough, this might be a simpler task than developing a client-server quiz app. First, it's because the chess app would be built on an existing engine, and there are numerous chess engines. Some are even available as Python packages. Just import it and you can play your chess game. That's easy. Second, the quiz is tricky because it's time-bound. The quiz state transitions we have to define and implement with care. In this sense, a chess game is simpler. The only state in a chess game is the figure's allocation to the square. If you want to keep the track of the game, again, there is a standard chess notation that's concise and self-consistent, and every chess engine recognizes the notation. Therefore, let's not underestimate our current challenge, as the complexity is somewhere outside the game logic. This is a state machine that represents the quiz application logic. Here, the quiz goes through the stages, starting from pending, then the quiz just created but hasn't started yet. And then quiz is scheduled. That would give other players some time to prepare for the quiz, to update their browser, or to make the browser update automatically. Finally, the quiz is started and the questions will follow in one another, players answering the questions until it finishes. And when the quiz is finished, the other state it could transition is only one option, the expired. The quiz could be expired also from the pending state if the quiz hasn't started for too long. Then the quiz is just created, the transition from pending to scheduled is performed by the user, so this is a trivial case. But then the quiz is started or scheduled. It should be automatically transitioned to the started state, and this transition should happen in a certain amount of time, so there is no user action in between of the scheduled and the started states. The same is true when a quiz is started and eventually it's gonna finish. Transitions between these two states should be performed automatically, and the time between the quiz is started and it finished might be substantial. So the quiz could take 5 minutes, and this is a bit too much for a Lambda. The Lambda function ideally is supposed to execute and finish the execution in less than a minute, maybe in a few seconds, ideally in milliseconds. How do we perform this transition, providing there is no server and there is no cron tab job that would execute the quiz expiration or the quiz started after being scheduled? Here is the answer. We don't care about the quiz current state until a user comes to check the state or maybe to post an answer to the quiz question. So at the present moment, the quiz could be live or could be expired already, but we don't know yet until someone comes to check the quiz, and this request would initiate the actual state transition if it's required. When the request comes from the user side, from the API client side, the Lambda would not only return the quiz state, but would update the state if necessary and return the updated state to the user. Let me show you how it works for our quiz that's in a pending state. It was created but hasn't started yet. The quiz is created, the quiz commander shared the link, maybe in a social network or in a messenger, and more people are joining the quiz. Now the quiz commander pressed the button start and this event scheduled the quiz. Suppose the current time is 12:05:11 and the quiz is supposed to be scheduled in 12:05:21. Time flies, but nothing's changing on the server side. The quiz is presently still in the scheduled state, even though there is already time to activate the quiz. The current state of the quiz is just scheduled, and the state's not gonna change until someone comes and execute any request against this particular quiz. Finally, one user updates his page, or maybe the page has got updated automatically by a client front-end script. This action initiated the quiz state transition, or maybe the client used the API directly and posts his answer to the question number 4, because the current question is number 4 and we could easily calculate it, provided we know the time at which the quiz has started and the amount of time between the questions. Even though the quiz state transitions happens couple minutes later when it's supposed to happen, still the quiz in the correct state, regarding the time that passed from the moment the quiz was gonna start. If we had a server that would do the same in the background, the current state of the quiz again would be started and the current question again would be number 4. This illustrates that even though they don't have a server that's running 24 hours, 7 days a week, we still can perform state transitions that are time-bound. But the quiz expiration is a special case. We might not need this expired state at all. Instead, we could opt for preserving the quiz's results in the database throughout our application lifecycle. But I would prefer saving a bit of money by not utilizing the storage for quite an amount of time. This kind of state transition is trivial to implement. Remember that our quiz internal state is being stored in the Elasticache Redis in-memory database. Redis database has an option of setting the time to life for each record we store. Later on, we'll see that the Redis is not an option, providing we are building a production-ready solution of our quiz website. But there is an alternative, and the alternative is DynamoDB. DynamoDB, as well as Redis, has again the option of setting time to life per records. With the state machine I showed and some general considerations, I described this API as a number of methods, the payload, and expected responses. Soon we'll be embarking on a journey towards our final goal, building a client-server application, deploying it on AWS, and automating the development process through Terraform scripts. Along the way, there'll be various pivots and intermediate stops to help us stay on track. The pivot points will be achieving a complete backend, followed by a complete client-server implementation that we can run and test locally, And finally, the AWS hosted solution. To get started, we'll be implementing the backend first. And I want to emphasize that my main focus is on AWS deployment. So the backend application will not be a production quality solution. Instead, it will serve as a rough proof of concept. Similarly, the frontend will not be top-notch either, as my skills in frontend development are limited. I'll be creating a static website with logic using vanilla JavaScript. If I were in your shoes, I'd probably skip the backend and frontend parts and head straight to the code repository and AWS videos. However, we'll be taking a more comprehensive approach. So, without further ado, let's dive into the backend.